Now let's first learn through an example how to conduct a hypothesis test when the population standard deviation sigma is assumed to be known. Okay, so here's the example. A car company claims that its new model can achieve at least 40 miles per gallon on average. Okay. Suppose the standard deviation of MPG for all these cars is 15, right? A sample of 100 cars use a sample mean of 37. Okay. Now, if the data don't support the company's claim, the cars have to be recalled. Right? Okay. Let's conduct the hypothesis test. At 1% level of significance. Okay. All right. Okay. So let's go through the 4 steps of a hypothesis test. Right? The first step is where we develop the null and the alternative hypothesis. Okay. So here, the parameter of interest is the population mean, right? How do I know that? The keyword here is average, right? So when we see the word average, we should be thinking about the mean. Okay. So the null hypothesis is the company's original claim, which is that mu is greater than or equal to 40. Okay. And then as a researcher, you want to reject the company's claim, and so you want to show that mu is less than 40. Okay. Now, looking at these hypotheses, we know that this is a lower tail test. Okay. Right. Now let's also specify what we already know, right? We know that we have a sample of 100, so n is equal to 100, right? That sample gives us a mean of 37, so x bar is 37. Okay. Now sigma x, the population standard deviation in this case is 15. Okay, how do I know that? I know that because we're told that the standard deviation of all these cars, right? Okay, when we're talking about all these cars is the population. Okay, and we know that the hypothesized value mu sub 0 is 40. That's the value that shows up in the hypotheses. Okay. So in step 2, we want to calculate the test statistic. Okay. So when the population standard deviation is known, the test statistic z is equal to x bar minus mu sub 0 divided by sigma x over the square root of n. Okay. Now we know all the ingredients to calculate the test statistic, right? This is, in the context of this problem, 37 minus 40 divided by 15 over the square root of 100, and that gives us -2. Okay. Note that we denote the test statistic z, right? This is gonna remind me that I'm gonna need to use the z table later on. Okay. Okay, so let's move on to the next step. In step 3, we want to formulate the decision rule. Right? Okay. Now there are two ways to proceed at this point. We can either use the p-value approach or we can use the critical value approach. In this video, I'll show you how to do the test using the p-value approach, and then in another video, I'll show you how to do the test using the critical value approach. Okay. So first off, let's note that the level of significance is 1%, so alpha is 1%, which is 0.01. Right? Okay. So the decision rule here is that we reject the null if the p-value is less than alpha. Okay. All right. So let's move on to step 4 when we reach a conclusion. Okay. So let's look at our decision rule. We know that we reject the null if p-value is less than alpha. We know what alpha is. Alpha is 0.01. Okay. But we don't know what the p-value is. Right? So what is the p-value? Formally, the p-value is the probability of obtaining a test statistic as extreme as, right, or more extreme than the observed value when the null hypothesis is assumed to be true. Okay. Now this is a mouthful, right? So how do we actually find the p-value? Let's note again that this is a lower tail test. Okay. So for a lower tail test, we find the so for a lower tail test, the p-value is the area under the standard normal curve to the left of our test statistic. Okay, remember that we know what the test statistic is in this case. In this problem, our test statistic was -2, right? So let's go ahead and draw the standard normal curve. Okay. Our test statistic here is -2, and so by this definition, the p-value is the shaded area, right? Okay, but this is just the probability that z is less than or equal to -2, right? Okay, so now it's already in the form where we want to find the probability that z is less than or equal to something. So all you have to do to find this probability is go into the standard normal table, look for -2 on the margins, and then look in the interior for the probability, right? So let's go ahead and do that. So you go to the standard normal table, look at row -2.0, and then look under column 0.00. That gives you a probability of 0.0228. Okay, that means that our p-value in this case is going to be equal to 0.0228. Okay, now the decision rule is we reject the null if the p-value is less than alpha, right? In this case, the p-value is 0.0228, which is greater than alpha of 0.01. So our decision is we cannot reject the null. At 1% level of significance. Okay. So what does this all mean? What's the interpretation of the test? Okay. The interpretation here is that at 1% level of significance, okay, the companies claim that its cars achieve at least 40 miles per gallon on average, cannot be rejected. Okay.